Okay, so welcome back, and today we're going to do one more example, part C, and we're going to take these two parametric equations and we're going to find the critical values by using the formula, the equation that we were introduced in the theorem. Okay, so let's do it. So what we need to do is we need to find x prime of t. So x prime of t is going to be what? The derivative of cosine is negative sine, so it's going to be negative 5 sine t. And then y prime t, the derivative of sine is cosine, so this is going to be 5 cosine t. And then of course, what do we get? Well, we get if we use, right, y prime of t divided by x prime of t, which is again dy dt over dx dt, right? So then it's just going to be 5 cosine t over negative 5 sine t, right? And so what do we get with that? So we've got a ratio, so we need to just find where the critical values are, right? So this is going to turn out to be negative cosine t over sine t. Okay? And so what is cosine t over sine t? Well, that doesn't look right. Cotangent. So negative cotangent t, right? Okay, so now here's the function, right? The slope function. And so when do we take, when is this equal to 0 and when is it undefined? Okay, so the derivative of 0 is 0 when cosine is 0. So if we go back to here, right? So again, we can see that this is 0 if cosine is equal to 0 and undefined when sine is equal to 0. So we can immediately see the behavior of what this thing is doing at this point. So this gives us t equal to 0, pi over 2, pi, 3 pi over 2, and 2 pi as critical points for t. Okay, so let's write that down. Okay, so where do I want to write that? Okay, so let's go back up to here. So we got this. So let's go back up to here because I don't want to erase the graph. Okay, so what do we got? We have critical values when t is equal to 0, right? When we have t equal to pi over 2, when we have, what else? Pi, 3 pi over 2, and 2 pi. So those are where we're going to find the critical values. Those are the critical values for t, or critical points for t. Okay? Now, substituting each one of these in for the parametric equations, we're going to get the following. Okay? So we don't need this anymore, right? We were just looking for the critical values. We got those. Okay? So now, we're going to plug these into x of t and y of t. Okay? So what do we get here? So when t is 0, what do we get? We get 1 times 5, which is 5, and this is 0. Pi over 2, we get 5, oops, not 5. We get 0, 5, and then at pi, we get negative 5, 0, and then at 3 pi over 2, we get 0, negative 5, and then at 2 pi, we get 5, comma 0 again. Okay, so again, this is all for t is 0, pi over 2, pi, 3 pi over 2, and 2 pi. Okay? So now, excuse me, let's plot these. Okay, so easy, right? 5, 0. Oops, wrong one. So 5 zeros here, and then 0, 5 is here, and then negative 5 zeros here, and then 0, negative 5 is here. So what do we get? Well, we end up getting, if you plot more points, what we end up getting is a circle like so. And so we see the critical points are horizontal lines at the points 0, 5 and 0, negative 5. And then we've got vertical lines at 5, comma 0 and negative 5, comma 0. And that's it. So now let's talk about finding the equation of a tangent line given parametric equation. But before we do that, let me give you one to work on. Okay. Here is one for you. So, x of t equals t squared minus 4t. Y of t equals 2t cubed minus 6t. And this is going to be on the interval from that t is greater than or equal to negative 2 and less than or equal to 3. So go ahead and do that one. And again, if you get stuck or if you run into problems, let me know. And I can confirm whether you did it right as well. Okay, see you next time.